There is a hard deadline baked into every AI system you have ever used. Not a metaphorical limit. A literal date. A specific moment in time after which the model knows nothing. ChatGPT, Gemini, Claude, Grok. Every one of them was trained on data collected up until a fixed cutoff point, then frozen. The world kept moving. The model did not. Right now, the AI answering your questions about current events, medical research, legal changes, and financial markets is operating from a snapshot of reality that is anywhere from 6 months to 2 years out of date. And most people have no idea that is the engine running underneath. This matters because we have crossed a threshold. As of 2026, an estimated 700 million people use AI assistants on a regular basis, and a significant share of them are using these tools to make real decisions. Not just writing emails, but researching symptoms, evaluating job offers, analyzing stocks, understanding new laws, planning businesses. When the AI confidently answers a question about the current price of NVIDIA shares or the latest FDA drug approval, it is not searching the internet. It is retrieving a memorized pattern from training data that may be 18 months stale. The consequence is not a minor inconvenience. A wrong medication interaction that was updated in a drug database 6 months after training. A tax regulation that changed after the cutoff. A merger that happened last year that the model has never heard of. These are not edge cases. They are the everyday reality of using a frozen mind in a moving world. To understand why this flaw exists, you have to understand how these models are built. Training a large language model is not like updating a website. It is closer to educating a child from birth to age 18. You expose the model to an enormous corpus of text, books, articles, research papers, websites, forums, and over months of computation. The model learns statistical relationships between words, concepts, and ideas. The process requires massive clusters of specialized chips running continuously, consuming enough electricity to power a small city. OpenAI's GPT-4 training run was estimated to have cost over $100 million. You cannot repeat that process every week to keep the model current. So developers pick a cutoff date, complete the training, and release the result. What the model learned up to that date is what it knows. Everything after is silence. Here is where it gets genuinely strange, and most people who use these tools daily have never thought about this. The model does not know what it does not know. When a language model encounters a question about something that happened after its training cutoff, it does not go blank or admit ignorance cleanly. It does something far more unsettling. It extrapolates. It generates a confident-sounding answer based on the patterns most likely to be statistically correct given everything it has learned, even if the correct answer changed dramatically after training ended. Researchers call this confabulation. The model is not lying in any intentional sense. It is doing exactly what it was designed to do: produce fluent, coherent, plausible text. It just happens that plausible and accurate are not the same thing. In one study published by researchers at Stanford in 2024, language models were tested on factual questions about events from 3 months before and 3 months after their training cutoffs. Accuracy dropped by nearly 40% for post-cutoff questions, but crucially, the model's expressed confidence dropped by only 11%. They were almost as sure of wrong answers as right ones. The second layer of this problem is more alarming than the first, and it is almost never discussed publicly. The training cutoff is not the real boundary. The real boundary is something called data density decay, a phenomenon where the most recent period before the cutoff is also the least well represented in the training data. Think about how information propagates on the internet. An event happens today, and there are 10 articles about it. 6 months later, there are 10,000 analyses, retrospectives, Wikipedia edits, forum discussions, academic papers. A major event that occurred 2 months before the training cutoff is represented by a thin slice of initial coverage. The same event from 2 years earlier is embedded in the model thousands of times over. This means the effective knowledge of a model with a January 2025 cutoff may functionally resemble a model that stopped learning in mid-2024 for anything recent. A 2023 analysis of GPT-4's training behavior found that the model's reliable factual accuracy began degrading roughly 4 to 6 months before its official cutoff date. You are not just working with an AI that is 1 year behind. You are working with one that is effectively 18 months to 2 years behind in any area that was still evolving close to the cutoff. So how does retrieval augmented generation, the industry's primary fix for this problem, actually work? Imagine the model is a brilliant scholar locked in a library with no windows. Retrieval augmentation is like sliding a newspaper under the door right before you ask a question. The system searches an external database for relevant documents matching your query, pulls the most useful chunks of text, and injects them into the prompt the model receives. The model then reads that fresh context and generates an answer based on both its trained knowledge and the retrieved material. It is a genuine improvement, and tools like Perplexity and the search-enabled versions of ChatGPT use this architecture. The counterintuitive part is what the model is actually doing with that retrieved text. It is not updating its knowledge. It is reading the document as if for the first time, every single time. There is no learning happening. The underlying model remains frozen. It is pattern matching against freshly delivered text, which means the quality of the answer depends entirely on whether the right document was retrieved and whether the model can correctly interpret material that may conflict with its trained priors. The complications here are real and worth naming clearly. First, retrieval systems can be gamed. In 2025, researchers at the University of Washington demonstrated what they called prompt injection through retrieval, where a malicious document embedded in a web page could be retrieved by an AI assistant and cause it to execute hidden instructions, leak personal data, or generate false information. If you are using an AI that browses the internet on your behalf, you are trusting not just the model, but every web page it touches. Second, the frozen knowledge problem creates systematic bias that compounds over time. Models trained predominantly on English-language Western internet data carry that perspective into every answer. And the longer a model remains deployed without retraining, the more its worldview diverges from current scientific, legal, and social consensus. A model deployed in 2024 and still running in late 2026 without updates has now missed 2 full years of climate research, 2 years of medical literature, 2 years of court decisions. That is not a small gap. That is a geological shift in human knowledge, rendered invisible by confident pros. What this means for you specifically depends on how you use these tools. If you are in medicine, law, finance, or any field where regulations, research, or market conditions change on a quarterly basis, you need to treat AI output as a first draft from an intelligent but outdated colleague, not as ground truth. Verify anything time-sensitive through primary sources. If you are building products on top of AI APIs, the cutoff date of your underlying model is a technical liability. You are legally exposing yourself to every time a user asks a current events question and your system answers confidently. The European Union's AI Act, which entered full enforcement in August 2026, explicitly requires disclosure of AI knowledge limitations in high-risk deployment contexts. Companies using models without that disclosure now face regulatory consequences. The practical watch-out is this: any AI that does not tell you its cutoff date and proactively hedge on recent information is the most dangerous kind. Confidence without currency is a specific kind of wrong. In the next 5 to 10 years, the architecture of AI memory will have to fundamentally change. Continuous learning, models that update in near real time from verified data streams without catastrophically overriding prior knowledge, is the unsolved technical problem that every major AI lab is racing toward. Google DeepMind, Anthropic, and a dozen well-funded startups have active research programs on this exact challenge. The model that cracks it will represent a step change larger than the jump from GPT-3 to GPT-4. Until then, every AI you use is a time capsule, an extraordinary, useful, genuinely impressive time capsule, but a time capsule nonetheless.